Well, hello everybody. Welcome to the second video in our three-part series about how to load data into D3. In the first video, we looked at some of the load functions and noticed that they use a callback function, and we started to manipulate that callback function so that we can massage the data into a way that we want for our D3 viz. We put all of that up onto the server, and I promised in the second video we would do the same thing on our laptops or our desktops, and that's what this video is all about. And you'll notice that we're going to find an error. It's going to be called the cross-origin resource sharing error, which is a lot of verbiage, but I'm going to go slightly down a rabbit hole today so that we can see exactly why we get this error. And then when we know how to work around the error, you'll understand better about why that's a good solution to this problem. The third video upcoming is going to be about the working with the asynchronous nature of JavaScript, and we will start to play more with the callback function in video 3, again, so that we can manipulate or massage or change the data as we're loading it from those external data files. All right, well, here I am down on the desktop of my laptop, and you can see I have a folder here called DataViz. This is exactly the code that we were running on the server in the last video. It's just living on my laptop right now. And so what I'm going to do is drop into Chrome for just a second, and I'm going to open this just as we were doing the entire rest of the class. But one of the things I want to do first is I'm going to open the JavaScript console down at the bottom. Again, there's some errors from Google. That's okay. Don't worry about those. Now I'm going to open this in exactly the way that we used to open it before, which is I'm going to go into the File menu, and I'm going to go to Open File, and I'm going to navigate. I'm already here. I'm navigating out to my desktop. If I'm worried about it, do that. I'm in DataViz. Here I am at dataviz.html, and I'm going to open that. Now, if this runs the same way that it did on the server, what I should see is a console log of all of those CSV values. And in fact, you can see I don't get that at all. And I get a vague error message that says that the fetch API can't load that. And it says the URL scheme must be HTTP or HTTPS for a CORS request. Well, this is exactly the kind of error that we were worried about. This is the cross-origin resource sharing error. Now, I'm going to open the same thing in Firefox. So I'm just going to go to Firefox really quickly. And I'm going to do the same thing under Firefox. It's Tools, Web Developer, Web Console. Here's my Web Console. Same thing. I'm just going to go to File, Open, search to my desktop, where I already am, and open the file. And here I get this. And I get a slightly different error message. It says the cross-origin request has been blocked because the same origin policy disallows reading the remote resource at blah, 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 blah. Now, one thing quickly in passing, you will notice if I look at my address bar up here at the top, I am not at an http://address. In fact, when I choose File Open, I use a different protocol or a different scheme, and you'll see it starts here with file://. You can ignore that third slash. That's the root directory of my laptop. So this is opening through a file protocol, but when we were working on the server, we were opening with an HTTP protocol. And that's really important, and that's the crux of this error. I'm going to go down here into the console window, and I'm just going to click on the Learn More. I get actually a really good error message page from the Mozilla organization. It says the CORS request is not HTTP, and if I start to read this page, you can see exactly what's up. The CORS requests may only use HTTPS or HTTP, but the URL specified is of a different type. This often occurs if the URL is a local file using file://. To fix this problem, make sure you're using HTTP all the time, right? There's a little bit down here about Firefox. I'll come back to that in a minute. All right, before we get too technical here, let's just do one other quick experiment. This is just a blank Chrome window, and we all know that we can type a question into the address bar. So if I just start typing, why is you'll see that we get a lot of recommendations for how to finish that search query, some of which provide us a little bit too much information. But here's what's happening under the hood. Google has written some JavaScript to look in that particular search box and to take note of anything that I type there. So this is an event handler that has been attached to that particular text box. As soon as I do a keystroke, I don't know what this is. Maybe it's an event of on change. Maybe it's an key up event. I don't know. It doesn't matter. We could look at the code, but it doesn't really matter. As soon as one of those events happens, what Google does is in JavaScript, it collects the text that I have already typed, and behind the scenes, it sends a message back to Google Home Planet. And at Home Planet, it finds the, whatever there are 6, 7, 8 here, most popular queries that begin with that string. It returns those, again, behind the scenes, and Google creates in the DOM tree a new window that goes in the front here. It's closer to us than the Google page. If you've played with your CSS lately, you know there's a z-axis, so the z-axis is closer to me. And it populates that with a list of these items, all of which obviously have mouse overs and all of which have click events attached to them, right? So if I click on that, it simulates, or it finishes, it populates that entire search query, and I go out to Google and I get my stuff back. This is a classic example of asynchronous programming. And so now let's dive down under the hood a little bit just to talk about how Google actually does this. So what's happening? Well, all of us who've ever worked on the web know that when we get into our browser, what we're doing is interacting with a server that exists somewhere out on the internet. And we know obviously how that works. So we're working in Safari or Chrome or Firefox or Opera or whatever. We click on a link, we type an address into the URL search box at the top. And what our browser does is sends a request to the server. These requests, believe it or not, are just written in plain text. They have a certain format, but you can actually kind of type these by hand on the command line if you want to dive down there far enough. But the server takes that request, processes it, and returns to us some kind of a response. If we're allowed to have those materials, we'll get back a web page or an image or streaming media, whatever. If it's not, maybe we'll get a 404 or some other kind of an error. Yeah. So this is the way that the browser works. Obviously, then, under the hood, there is some software that knows how to handle requests and responses. And there's a little homunculus in there, or more specifically, it's a software object under the hood that sends requests and gets responses back. The cool thing about this is that we, as programmers, can have access to that object as well. And that's how Google does that search. That object that's under the hood has the nifty name of an XML HTTP request object. It just rolls trippingly off the tongue. From some of the other videos, or if you've taken a class with me before, I like to think about software objects as the Death Star. So objects are composed of these two kinds of components, things that they know and things that they do. And the XML HTTP request object is one of these things. It knows how to formulate a proper request. It knows how to send it. It knows how to handle the response when we get it back. And it has a whole bunch of status information in there that we can access and that we can work with. So it's possible for us to go in and actually program our own XML HTTP request objects. We can create as many of them as we want to, which is totally fine. Well, guess how D3 loads a file? Exactly. It doesn't do file open. It actually creates an XML HTTP request object. And it uses that request object as a way to bring in our CSV file, or our TSV file, or our JSON file, or our XML file, or whatever we happen to be working with. This technique is actually called Ajax. It stands for Asynchronous JavaScript and XML. There are tons of good books about that. Here's a really interesting one. You know, I like the Head First series. Head First Ajax is a great lesson about how to do this. Working with Ajax requires a few different techniques. So what happens is, we've seen already behind the scenes that Google sends out information back to the home base. That's happening independently of what we do on the front side of the page. That is called asynchronous. That these two things are not in harmony or sequence with each other. So the XML HTTP request object can go about doing its business in the back end, while in the front end, we're just doing something else completely different. Those two processes are very, very, very independent of one another. This is one of the reasons why loading D3 datasets requires us to understand something about the asynchronous nature of JavaScript, because it's actually using Ajax under the hood, which is all asynchronous. Some people say that Ajax is a different programming language, but that's ridiculous and just patently untrue. It's just JavaScript. We're just using JavaScript to work with that XML HTTP request object. That's all that it means, right? The XML part, by the way, is sort of old-fashioned. There was a dream of one ring to rule them all in the old days, and that one ring to rule them all would be XML. We know now that XML is just one of many different kinds of data formats. So today we use more JSON, much more JSON than we ever do XML. But for some reason, Ajax just doesn't really have a good ring to it. So nobody calls it Ajax. It's still Ajax. What I would do, if you're interested in that, look for a book like Head First Ajax, or just go Google the W3 schools Ajax. They have a really nice tutorial there, and you can see a lot more about it. There's some very, very interesting programming strategies that you can use when you work with Ajax. But again, the more we know about Ajax, the more this D3 data loading process is going to make sense to us. But there's more. Not only does D3 use Ajax, and so we have to go through an HTTP request in order to get our external data, the Ajax object itself has to adhere to what we call the same origin policy. What the same origin policy says is that when I request two different resources, the second resource must match these three principles of the first resource. Right? So here at the top, I have a fake URL. We're going to talk our way through that. So the first part of the two resources that have to be the same is called the scheme or the protocol. You'll notice that when we were working on the server, everything is in HTTP://. That is really amenable to an Ajax object, right? But the file:// which is how I have my my document, my D3 documents open when I go through File, Open, you'll see that the scheme or the protocol here is really different. One is HTTP, Ajax loves that. The other one is file://. Ajax can't do that at all. So immediately we fail the same origin policy because we don't have the same scheme or protocol, but it gets worse. The second part is called the host or the domain. Here it's www.example.com, but you'll notice that we don't even really have a host or a domain down here. This is actually just a file path on my local machine. So it doesn't have kind of international web internet status, right? So there's a complete mismatch here as well. So we're failing on two counts. We got two strikes going against us. Here's a third one that you might not have seen before, but is pretty important as well, which is that there is a particular port or you think about this as a door. So the default door or port on any web server is port 80. So if you think about a web server as having a whole bunch of doors, they all have numbers on them. They're all closed except door number 80. At door number 80, that's when new visitors can come in and make requests, and we can send requests out, etc., etc., etc. Now, unless I specify otherwise on any web URL, we're always working with port 80. But you'll notice in my example URL up here at the top, we're going to a different port called 8888. And you'll notice there's a colon there after the domain name, and then we're opening a port. We're going to be doing this again here in just a second. So 3 strikes, we're out. We only needed 1 strike, but we've got 3 strikes and we're out. We haven't matched the scheme, we haven't matched the host, and we haven't matched the port. So the same origin policy fails, and that's why we get that nice, especially in Firefox, we get that really nice error message. All right, so now finally, let's talk about how to solve this problem. I have a few options available to me, but I'm going to show you the one that I think is the best first. It involves Python, actually, believe it or not. So here I am on my desktop, and what I want to do is, if I'm on a Macintosh, I just want to open a terminal window. If you've never done this before, the terminal window is an application. Go into Applications and go into Utilities and click on Terminal Window, open it up. If you're on a Windows machine, Windows doesn't come with Python loaded automatically. And in fact, Mac comes with an old version of Python. So if you've never worked with Python before, what I would recommend is actually going and downloading the Anaconda package. You'll get the newest version of Python, which I think is about 3.7 right now. And you get a whole bunch of other great utilities as well. So if you're on a Macintosh, open your terminal window. If you're on Windows, go into Anaconda and open the PowerShell. Don't open the Python shell because that dumps you into the Python interpreter, and that's really just not where we want to be right here. So what I want to do in Python is actually start a web server on my laptop. And I'm going to do it in the folder where my D3 stuff happens to be. So again, my D3 stuff happens to be out here on my desktop in DataViz. So what I'm going to do is change directories into my home directory, and if I do listing in long format, you can see what's there. There's a folder called data, there's HTML, DataViz, etc., etc., etc. Now here's what I want to do in Python. I just want to type Python -m http.server 8888. So what I'm doing is I'm telling Python to go open a module, that's the -m switch, and that module is called http.server. Now, what that means is under the hood somewhere, there's a file called http.server.py. Python's going to go find that, and it's going to execute that. Obviously, what you can see is that that's going to start a little tiny web server on my laptop. And guess what the 8888 is? Yes, that's the port that I want to use. So for this web server, every door will be closed except the secret door 8888. And that's the one that I'm going to be accessing. And if I hit return, you'll notice that now it says I'm serving HTTP on such and such an address at port 8888. Now, do not close this window. You can minimize this window, but don't close this window, because if I close it, then my server will stop executing, and I don't want that to happen. So what I'm going to do now is I'm just going to drop back into Chrome, and here is the page that I had open a little earlier. You can see in Chrome this is a file : / and down at the bottom I get all of these error messages. So now I want to go to a new URL. I'm going to go to http://localhost:8888 and the page, dataviz.html. So what I'm doing now is I am actually using the HTTP protocol. I'm running on this little tiny baby web server. And so I'm surfing to this particular machine, which has a pronoun name called localhost. And the :8888 says I'm requesting stuff through the port or the door labeled 8888. When I started the server in the command line, I said, please listen for people on 8888. Yeah. And so I'm requesting the file dataviz.html. And so you can see that all of this loads up perfectly fine. And so you'll see we get just what we got before. I get my data set, my CSV data set in exactly the way that I did. And if I ask for all caps data set, there's my data set as just as I saw it before. And I can see that I have an array of 0 to 3 items, and each one of those is a little tiny JSON object. All right, well, let's finish up. If I go back to my terminal window, you'll notice what's happening now, which is that the server is actually creating a log of the different things that I've been doing. So you'll notice there are some GET requests here, and I am all going to the IP address 127.0.0.1. That is a synonym for the name localhost. And you'll see that I'm requesting several of these pages. There's a 404 there for the favorite icon, no big deal. But you'll notice that a lot of these are response code 200. That's interesting because 200 is success. We very rarely see 200, but still, that's good. So I'm just leaving this open. As long as I want to work on my page, I'm leaving this open. It will continue to log stuff into this error log. It's not even really an error log, it's just an activity log. But when I want to quit, what I can do is go back, hold down the control key and hit C, and you'll see that that gives a keyboard interrupt, and that actually stops the server. So now I'm back in the regular command line window, and I can continue to use the command line if I want to. I could also alternately close this window, and when the window closes, all the processes inside it will close, which means the server will shut down as well. But I can boot it up again really easily. The trick is that I have to change directories to the place where my D3 files are, and then start the server from there. I won't be able to navigate around into other folders because the web server, that little tiny baby web server, is going to be a little bit protective about being in this particular directory. But this is now how I can continue to develop on my laptop. All right, well, just as a summary here are 5 different solutions to this problem. I'll talk through them really quickly, but you can see my preferred solution here now is number 5 down at the bottom. This is the one that we worked our way through. But just really quickly, you'll see some of these around floating around the web, but one is to find an old version of Firefox. We saw on that Mozilla page earlier that Firefox, in a version older than I think 68, it actually violated the same origin policy, and so you can find Firefox. In fact, I've been teaching D3 for a long time, and we used to tell everybody to get Firefox. But that isn't really the case anymore, but still, it's probably an option. And number 2 isn't really ideal either, which is just to create a new JavaScript library and put some bogus data in there. It's exactly like what we saw at the beginning of the first video in the load data series, which is that hard coding that data just isn't dynamic enough. It's not big enough. If we want to work with really big data sets, we've got to do it differently. Still, if you're in a pinch, if you're in a bind and you just need to do some debugging or testing, just create some bogus data and just load it like any other JavaScript library. The third one is actually a potentially viable solution for you if you'd like, which is to work directly on the server. For us, obviously, that's the HucoDev server. There are 2 caveats that I would give you if you're going to do that. Number 1 is your FTP software, File Transport Protocol software, somewhere in the preferences is going to be a setting for how long to keep the connection open to the server with no activity. Sometimes this is called a keep alive setting, and you can put a number in there, like maybe the number of seconds to keep that connection active with no activity. I think in FileZilla, I think you can actually put a 0 in there, which says please keep it alive forever and ever and ever. But even if you change that, there's no guarantee that you won't get unceremoniously dumped off the server, because the server keeps track of it too. And I think it's a very, very short period of time. It might be 2 minutes. I don't know what it is. So even if you change the settings in your FTP software, you may still get dumped by the server. So you're working very diligently, you go have lunch, you go get some coffee, whatever, and you come back and the server dumped the connection. That's totally plausible. Number 4 I put on here because you'll see this commonly on the web too, although I'm not going to talk about it, which is, especially on Windows, you can install a web server using a product like WAMP or XAMPP. Those are easily downloadable. You also get some other stuff like a MySQL database. You get some P scripting languages like I think Perl and PHP maybe. And what you do is you create a folder, and that folder is accessible to a web server as well. If you're on a Mac, there is MAMP, but you don't need that. Go into your preferences and you can start the Apache web server. which you have installed by default. And then you can start to put files in system library, web server, documents, etc., etc. This is a good way to develop, but it's a little bit more work than you really need to. Obviously, my strategy is number 5 here is just use Python to create a mini server in the directory that you have your D3 code in. Again, right there is the command python -m http.server8888. If you want, that Scott Murray book, Interactive Data Visualization for the Web, talks about this really briefly in chapter 4. So if you want to go read some stuff on it, you can go look in his book in chapter 4. And again, just to use that in your browser, then just surf to http://localhost:8888. You should be able to go also to 127.0.0.1:8888, and then just put the file name at the end, and you'll be fine. So this is the way to get around the cross-origin resource sharing problem, and it's a way to obey the same origin policy and to work on D3. Obviously, once you get all of this all ready to go, just upload it all to the server, and then we'll be ready for your final assignment. All right, thanks and good luck.